across the plant types. So in discussion, in the swell, the FTI spectra and the band ratios, they generally suggested that the switchgrass contributes to more carbohydrate-associated labile carbon, whereas the switchgrass has higher aromatic enrichment, suggesting the relatively greater chemically complex swell organic matter formation under the gamma grass. Whereas in case of the tissue level, there was the variation in case of the ratios, which suggests that these ratios they might have remained influenced by the changing proportion of the carbohydrate, aliphatic, and the aromatic compounds, whereas the spectral mismatch between the FTI spectra and the band ratio in case of the plant tissues might be because the FTI ratio they generally reflect the relative band relationship and the overlapping functional groups rather than the absolute compound abundance. So in conclusion, the swell functional group evidence they consistently support the relatively greater recalcitrance, chemical recalcitrant under the gamma grass as shown by the previous study, which helped explain that greater swell organic carbon as shown by the previous studies. And in case of the shoot and the root, the functional group pattern also partially support the greater chemical recalcitrance under the gamma grass, but the tissue level differences, they were not as consistent as the swell level. And some of the ratios, the ratio-based responses, they did not fully align with our spectral trends. And so for overall, the functional group analysis, they generally support our hypothesis, but the additional work is needed as there are mixed signals in case of the ratios. So with these, the take-home message from this study is that previous studies, they showed greater carbon storage under the gamma grass. And this study, our study, adds the functional group evidence suggesting that the greater chemical recalcitrant or the complexity may be one of the mechanism for the differences in the swell organic carbon between two of these crops. So with these, for the acknowledgement, I would like to thank my major advisor, Dr. Janvi Lee, for providing me the opportunity to conduct this research, and my lab members, Dr. Lahiru Gamage and Matthew Manu, for constantly supporting me throughout this research, and the Department of Environmental Science and Tennessee State University for providing the research and lab facilities, the ARD Symposium for providing me the platform to present my work, and the Center of Excellence Grant for funding this research. Thank you, and I'm open for questions.
Very nice presentation. Good science. I'm just wondering, just before that clarification, this gamma grass is also C4 system?
Yeah, gamma grass is also a C4 crop.
So do you think, flowering pattern between switch grass and gamma grass, does this affect uptake or combination of carbon?
Might be, but I have not looked that deeper into the flowering patterns, so I'm not quite sure about that. Sorry about that.
So I'm just curious, is that the grass family is so big, why did you choose these two only?
Basically, first of all, for the switchgrass, it is one of the modal bioenergy crop that has been chosen by the US Department of Energy. And for the gamma grass, it is the growing perennial crop. So basically, these two are the major perennial bioenergy crops. That's why we chose two of this crop for the comparison.
My second question is that with regards to your methodology, did you grow them in a greenhouse, or did you collect them from county A, county B, and come up with those results?
No, it's a field research. We grow the switchgrass and gamma grass in the field in the TSE.
And what experimental design you applied there?
No, there was no proper experimental design. It was the sample was randomly collected from two of these fields.
So, thank you very much for your good presentation. One of my questions is, so we have a different options of increasing the soil organic carbon content. So, why are you specifically focusing on the grasses? Because we could have different ways probably better than this. Why is more, or why you want to focus on the grass?
I think using the grasses, it would be more sustainable way and more easier way for the soil organic carbon sequestration. I believe that's the reason.
For the second question could be is, so for your FTI, so you do the absorbance, right?
Yeah.
So why didn't you measure the transmittance? What's more special about the absorbance?
Actually, the FTI that we use, the ATI FTIR, it was already fixed in the absorbance, and most of the research, that study that I did was on the absorbance. That's why I majorly focused on the absorbance rather than the transmittance.
Thank you.